Dear students, in this session let us discuss about linear congruences. Let us see the definition of linear congruences. A congruence of the form AX is congruent to B mod M is called a linear congruence in X. A congruence is of the form AX is congruent to B mod M is called a linear congruence in X. Suppose the value of X, say alpha, satisfies the congruence, then alpha is called a solution or root of the congruence. Here X is unknown. Okay, we have to determine the value of the unknown. If alpha is a solution of this congruence, then alpha is called a solution or root of the congruence. That solution is written in symbol like this: X is congruent to alpha mod M. Here the value of X is alpha. Okay, alpha is a solution. Alpha is a solution. Also, this congruence may have infinite number of solutions also. Okay, that solution set is written like this: X is equal to alpha is one of the solution. Okay, alpha is one of the solution. The solution set is written as X is equal to alpha plus k times of M. M is the mod value and k is an integer. Is a solution set, or we can call it as a general set of this congruence. Now let us see the important concept: existence for the solution AX is congruent to B mod M. Okay. Now this given linear congruence may be a unique solution within the mod M, or some linear congruences may be a 2 or 3 solutions within the mod M. Some linear congruences have no solution. Okay. Then let me see how to verify given congruence has a unique solution or more than one solution, or solution does not exist. On which condition? Let me see. The first condition is if the GCD of A comma M, here A coefficient of X and the mod value. Okay, if the GCD of A comma M is 1, then the congruence will have unique solution. Okay, if the GCD is 1, then this congruence is a unique solution within the mod M. And second one, if the GCD of A comma M is say D and D divides B, is important. Okay, if the GCD of A comma M is say D, and if this D divides this B, if it divides, then the given linear congruence have D incongruent solutions. Incongruent means distinct solutions. That means more than one solution. So within the mod M. Some linear congruences have no solutions. On this condition happens if A comma M, the GCD of A comma M is say D, and D does not divides B. Here B. Okay, if the GCD of A comma M is say D and D does not divides B, then the congruence has no solution. Let us take an example. Verify the congruence 5x is congruent to 7 mod 8. Okay, has a solution or not. Okay, if it has a solution, let us find what is the solution, and solution set. Okay, ensure that the what is the GCD of the given congruences. Okay, depends on that GCD, we can say that whether this given congruence has a unique solution, or more than one solution, or solution does not exist. We can examine on the basis of GCD. Now take the coefficient of x is 5 and the mod is 8. Okay, let us find the GCD of 5 comma 8. Here take the least number as a divisor, and another number as a dividend. Okay, if I divides 5 ones are 5, we will get 3 is the remainder. Till continue this process till to get the remainder is 0. Next take the remainder is 3. Take again 5. Okay, 3 ones are 3. You will get 2 is the remainder. Again take this 3. Yeah, again 2 ones are 2. You will get 1 is the remainder. Again 1 2s are 2. You will get 0. Stop this process, division process. We get the remainder is 0. We know that the GCD is a last non-zero remainder. This is last non-zero remainder. Therefore, 1 is the GCD. What we discussed in the previous, the condition for existence, if the GCD is 1, the given congruence is a unique solution. Within mod 8. Let us find out which is the unique solution. If the given congruence 5x is congruent to 7 mod 8, next 8 divides 5x minus 7. Since mod 8 is there, okay, it's a small number, we can find out by inspection also. By inspection, if x equals 3, if you replace x equals 3, 5 3 is 15, minus 2, you'll get 8 divides 8. Therefore, x equals 3 is a solution. If you replace 0, you'll get minus 2 does not divides, 1 does not divides. Okay, if you replace 2 also, 8 does not divide. So only 3 divides this relation. Therefore, x equals 3 is a solution. Therefore, the solution can be written in the form of like this: x is congruent to 3 mod 8. Now let us write the solution set. Okay, the solution set is of the form x equal to the within mod 8, 3 is the solution. Write down here 3 plus k times of 8. 8 is the mod value. Okay, k is an integer. If I replace k is equal to 0, you will get 3. If I put 1, you will get 11, like this. Since k belongs to an integer, replace minus 1, you will get minus 5. So therefore, this is the solution set. Observe here, we find out the solution and a solution set. Okay, this is a solution. Okay, this is the solution set by inspection method. There is one more method. Without inspection method also, we can find out the solution and a solution set. Written alternative method without inspection method. Okay. Take the given congruences. If 5x is congruent to 7 mod 8, as 8 divides 5x minus 7, let 5x minus 7 is equal to 8. Okay, then x is equal to 8k plus 7 divided by 5. Here k is an integer. Okay, now let me see how to write the solution set. You go on replace, replace the values of k for k is equal to 0, plus 1, minus 1, plus 2, minus 2, like this. If you replace here, if I replace k is equal to 0, you will get 7 by 5. But fraction is not allowed in a number theory. We know that, correct? So therefore, 7 by 5 is not an integer. Therefore, reject this 7 by 5. If you replace k is equal to 1, you will get 15. 15 divided by 5 is 3. Okay, so like this, substitute for 2 plus 2 minus 2 plus 3 minus 3, like this, you will get an integer. Okay, this is the solution set, and that means you can find out the solution and the solution set by inspection method, or by alternative method is without inspection method. If mod value is very least value, we can prefer by inspection method. If mod value is a big quantity, better to go for this method. Let us see one more problem. Second problem. Verify 63x is congruent to 4 mod 7 has a solution or not. If there is a solution, let us find out the solution and a solution set. As I said, ensure that what is the GCD. Okay, depends on that GCD we can say whether the congruence has a unique solution or more than one solution, or solution does not exist. Here in front of x is 63 and mod 7 is there. Take the division. 7 8s are 56. 7 is there. Again take 7. Okay, 7 1s are 7. You will get 0. You can stop the division because we arrive at 0. Last non-zero remainder is what? 7. Therefore this is the GCD. So 7 is the GCD. After obtaining the GCD, okay, other than 1, verify whether this GCD divides the 4. So but 7 does not divide 4. The given congruence has no solution. Next, another problem. Verify 63 is congruent to 9 mod 15 has a solution or not. If it has a solution, let us solve this one. Okay, again in front of x, that is 6 is there, and mod 15 is there. Here the 6 2s are 12. We'll get 3 is the remainder. Again take, that is 6 3 2s are 6, 0 is the remainder. Last non-zero remainder is 3. Therefore GCD is 3. But this GCD 3 divides 9. Okay, here 3 divides 9. Therefore the congruence has 3 incongruent solutions. Okay, so because 3 divides 9, therefore the congruence has 3 incongruent solution. Within mod 15 there are 3 solutions, different solutions are there. Let us find out what are those. I prefer this without inspection method, or with inspection method also you can done, but I prefer without inspection method because 3 incongruent solutions are there. Okay, I prefer this one, or you can go for with inspection method also. Here I prefer inspection method. Take this 6x is congruent to 9 mod 15. By definition of congruence, 15 divides 6 minus 9. If it divides, you will get another third integer k. So 6x minus 9 is equal to 15k. As usual, x is equal to 15k plus 9 divided by 6. I simplified this by taking 3 as common outside. You will get to 5k plus 3 divided by 2. As I said, k belongs to an integer. You replace. Okay, k is equal to 0, 1, minus 1, plus 2, minus 2, plus 3, minus 3, like this. After substituting, simplify these integers you will get. Okay, if you get fractions, reject them because in number theory we are dealing with integers only. Okay, the solution set becomes -1, 4, 9, 14, like this. Okay, thank you.